We're all interacting with AI constantly, right? We ask it questions, we get it to summarize things, maybe even write a bit of code. But have you ever really stopped and thought, how does it actually get what we're saying? Well, today we're going to do just that. We're going to build an AI mind, right? From the ground up, piece by piece, to see exactly how the magic happens. Let's dive in. So, this is the big question, isn't it? It can feel like some kind of wizardry when you type a question and get a perfect answer back. But it's not magic. It's actually a really fascinating step-by-step process that's all designed to decode the beautiful mess that is human language. And we're going to walk through that entire process right now. Okay, so first things first. Before an AI can think or write or reason or do any of that cool stuff, it has to learn how to read. This is the absolute foundation. We have to figure out how to take our words, our sentences, and turn them into something a computer can actually work with. At the very heart of all this is something called a large language model, or LLM. And, if you strip away all the hype and all the jargon, an LLM really only has one surprisingly simple job. It's a prediction engine. So if you give it the phrase, all that glitters is not, its entire existence is geared toward figuring out the most likely next word is gold. It seems basic, but believe me, that one simple function is the key to everything else. So how does it even start reading? Well, it doesn't see words the way you and I do. It sees things called tokens. This process, which we call tokenization, is kind of like breaking our language down into Lego bricks. And what's really fascinating here is that last token, ers. The AI is smart enough to learn that bits of words, like suffixes, carry their own meaning. It's the very first step toward understanding grammar and the structure of how we talk. But just having those Lego bricks isn't enough. To give them actual meaning, the AI plots every single token on this enormous, multi-dimensional map. Think of it like giving each word part its own GPS coordinate for meaning. On this map, words like happy, joyful, and ecstatic are all clustered together in the same neighborhood, while a word like sad is way across town. This meaning map is how an AI begins to grasp relationships between concepts. Okay, so the AI knows what individual words mean, more or less. But that's not nearly enough, right? Think about the word bank. Is it a place for money or the side of a river? Or bat, an animal or something you swing in baseball? The next huge breakthrough was figuring out how to teach the AI to solve this puzzle. And the answer, the key to everything, is context. Just take this word, for example. What do you think of? Is it a fruit? Is it a multi-trillion-dollar tech company? Maybe it's a term of endearment. On its own, the word is totally ambiguous. Its little GPS coordinate on that map of meaning is just kind of stuck in the middle, totally unsure where it's supposed to be. And here it is. This shows the solution perfectly. The second you add other words, the context, the meaning snaps into focus. The word tasty literally pulls the meaning of apple over to the fruit section of the map. But if you add the word revenue, that same meaning gets yanked all the way over to a different neighborhood with concepts like stock price and CEO. Context is king. So how does the AI actually do this? It uses this absolutely revolutionary idea called the attention mechanism. The best way to think about it is like a spotlight that the AI can shine on a sentence. It learns to pay attention only to the most important words for context, like tasty or revenue, to figure out exactly what an ambiguous word like apple means in that specific situation. This right here was the game changer for modern AI. Now, this attention mechanism was so powerful, so effective, that it became the core of a whole new kind of AI architecture, the transformer. If the LLM is the car, then the transformer is its engine. It works by stacking these attention layers, one on top of the other. Each layer analyzes the sentence from a slightly different angle, which allowed the AI to understand not just direct context, but really deep, complex relationships, nuance, and even things like sarcasm. So, we have our engine. But an engine needs fuel, right? How does an AI go from just understanding basic sentences to knowing about quantum physics or Roman history or how to write a sonnet? Well, it has to be trained. It has to learn. This is where things get really, really clever. Instead of having humans sit down and try to teach the AI everything, which would be literally impossible, the model essentially teaches itself. It's called self-supervised learning. It just goes out, grabs a sentence from the internet, hides a word, and then tries to guess what that hidden word is. By doing this trillions and trillions of times, it just naturally learns grammar, facts, and the deep underlying structure of language, all without a human teacher insight. Okay, so that massive self-training process creates what we call a base model. And a great analogy for it is a new university graduate. It's really smart, it knows a little bit about everything, but it's a generalist. For a specific job, you often need a specialist. So you take that base model and you fine-tune it on a very specific set of data, like legal documents or medical textbooks. That's like sending your university grad to medical school to become a doctor. And this is where we humans come back into the picture. To make sure the AI isn't just smart, but also helpful and safe, we use human feedback. Let's say the AI gives two possible answers to a question. A human reviewer will look at both and rank which one is better, more accurate, more helpful, less harmful. The model then gets rewarded for the good answer and learns from the bad one. It's basically a massive good bot, bad bot feedback loop that steers the AI toward being a genuinely useful assistant. All right, so the AI is built, it's been trained finishing school. Now what? How do we take all these powerful concepts and actually put them to work in the tools that we're all using every single day? You know, one of the biggest problems for an LLM is that its knowledge is stuck in the past. It only knows what it was trained on. So how does it tell you about today's news? The answer is a technique called RAG. And the absolute best way to think about RAG is like giving the AI an open book test. Before it even tries to answer your question, the system goes out and finds relevant, up-to-date information and gives it to the AI as a cheat sheet. And here's basically how that works. Let's say you ask about a company's latest earnings report. First, the system finds that exact document. Then it hands both your question and the report to the AI and says, hey, answer this question, but only use the information in this document. This is so important because it forces the AI to base its answer on provided facts, which massively reduces the chances of it just making stuff up, or what we call hallucinating. So where is all of this heading? Well, the next major evolution is already starting to happen: AI agents. We are moving from an AI that's like a search engine to an AI that's more like a collaborator. It's not just a tool for finding information anymore, it's becoming a tool for getting things done. The only real question left is, what are we all going to build with it?